Welcome to Mechanical Education Hub. Today we'll study about impact of jet when our water jet will strike on stationary inclined plate. Jet strikes on stationary inclined plate. Let us consider a fixed or stationary inclined plate making angle theta with horizontal axis. This is our nozzle from which water jet is coming. Now water will spill into two halves, but here in this case we don't know that water will exactly spills into two equal half. So I am considering that water jet is coming with mass flow rate of m dot kilogram per second, and from here water leaving the plate with m1 mass flow rate, and from here water leaving this plate with m2 mass flow rate. So here we will get our first equation, that is m dot will be m dot 1 plus m dot 2. I'm using this dot because we represent mass flow rate with dot. Now if this angle is theta, then this angle will also be theta. Water is coming with Fj force. Now if we draw a perpendicular of this plate, then it will be something like this. This will be perpendicular to the plate, and if this is perpendicular 90 degree to the plate, this angle is theta, then here we will get 90 minus theta. Remember, this is our x-axis and this is our y-axis. I am considering water is coming with velocity v1 and exiting with velocity v2 from both the exit points, and if this surface of plate is frictionless, then v1 will be equal to v2. Discharge here we have, and this discharge will equal to area into entering velocity of water jet. Now let us calculate force in normal direction. If we have this v1 striking this plate, and this plate is forming angle theta with horizontal axis, normal to the plate is this direction. If this vector v1 or velocity vector v1 is striking this plate, we can split this velocity vector v1 into its sine and cos component. Now this cos component will get in direction normal to the plate. Now this normal will be our v1 cos 90 minus theta. So we remember the formula that m dot v1, force is our m dot v1 minus m dot v2. In my last video, we find this formula, we use this formula, that how by using this formula we can calculate impact of jets. Now this is momentum at entry and this is momentum at exit. Now from here, mass flow rate is m dot, and in normal direction our entry velocity will be this v1 cos 90 minus theta. Our entering velocity will be the cos component of this v1, that is v1 cos 90 minus theta. Minus, we'll have in exit, at exit point we have m1 and m2. Now m dot 1 into here our normal velocity is also 0 at exit points, because water will exit in this direction. So in perpendicular to the plate direction, our exit velocity will be 0. So m1 into 0 plus m2 from here, m2 into 0. So we get Fn will be, or no, force in normal direction will be m dot into v1 cos 90 minus theta is equal to sin theta. So from here we can also write this mass flow rate in be density into area into v1. Now v1 sin theta, and this will get rho a v1 square sin theta. This will be our force in normal direction. Now if we calculate force in a x direction, then we need to split that component, this component of force in its x and y, or we can say horizontal or vertical axis. Now this is our plate, and this is the direction of normal force to the plate. This will be our Fx, and from here this will be our Fy. We have this angle to be 90 minus theta. Here you can see that this is our normal direction, so Fn will be along this direction. If we split into sine and cos component, if we split this normal force into its sine and cos component, we will get Fx equal to Fn cos 90 minus theta, which will be equal to Fn cos 90 minus theta is sin 90 minus theta. Sorry, Fn will be cos 90 minus theta is sin theta. So force in x direction will be, we have Fn, that is rho a v1 square sine theta into sine theta. This will get rho a v1 square sine square theta. Now in this case, force in x direction will be this. In our previous case, force in normal direction or in x direction will be same, but here when our plate is inclined at angle theta with horizontal axis, our force in x direction will be the cos component of force in normal direction. Similarly, we can also calculate Fy. Fy will be our sine component of this force in normal direction, and it will be Fn sine 90 minus theta. This we can write this sine 90 minus theta will be our cos theta. So from here, Fn sine theta will be, Fn sine 90 minus theta can also be written as Fn cos theta. So force in y direction will be rho a v1 square sine theta into cos theta.